Hello Year 10 and welcome to your home learning tasks for this week beginning the 6th of July. We're looking at the topic of forces, as you know, and this week we're going to focus on the aspect of acceleration and how we calculate acceleration. In this short video, I'm just going to lay out some of the tasks for this week. There's just a few tasks for you to do, and I'm going to run through some of the equations with you, guide you through how to interpret and use those. Okay, so first of all, there is a starter or an introduction video that I would like you to watch. So you can pause this video at this point now, and you can follow that link, which will be available on the PowerPoint and also will be added to Teams and to Go for Schools for you as a link. Whilst you're watching the video, there's just 3 questions I'd like you to think about. First of all, before it starts, who do you think will win the race? Okay. Why did you choose them? And then as you watch the video, I'd like you to think about what factors influence how quickly something can accelerate. Okay, just some thoughts for you to jot down. Okay, the first task that I'm going to ask you to do is around some of our misconceptions and preconceptions on this topic of acceleration and forces. So just using your prior knowledge, your understanding, some of your own ideas and things, I'd like you to attempt the questions that I will provide on some separate sheets. You can either print out and complete, or you can just record your answers to them in your notes, just label them correctly, add them to Teams or email them so that I can address any misconceptions that we might have in relation to acceleration and motion forces, and I can look at those separately when I'm planning for our future lessons. Okay, so those will be added separately as documents for you to download. Okay, the second task and the bulk of this video is around the key concepts and equations that we're using looking at acceleration. So you're going to need to take down a few notes from this, and you're going to need to do a few calculations using the worked examples that I'm going to go through. So first of all, what do we mean by acceleration? So acceleration is the rate that an object's velocity changes. And just as a reminder, velocity is the speed of an object in a specific direction. Okay, so acceleration is just how quickly that velocity changes over a period of time. And we calculate it using this following equation. Okay, so I'd like you to write that down into your notes. A equals delta, that triangle shape, which you will have seen before. Okay, so delta V divided by T. So what does this all mean? So the first part, the delta V, is the change in velocity. Okay, so that's how much the velocity changes, and it's measured in meters per second. So make a note of the units as well. The second point underneath that is the time, and that is measured in seconds. So that's how quickly or how much the velocity changes over the period of time. And that obviously gives us the acceleration, and the units for that are meters per second squared. You can see that we have seconds above and below the equation, so therefore we end up with a unit of meters per second squared. This is an equation you need to learn. Okay, it's not one that you get given, so you need to remember it. So make sure you've got it clearly labeled in your notes and add it to your formula kind of flashcards and things like that, whatever you use for your revision. Okay, so using this equation, I'd like you to attempt these questions. Okay, so you can pause the video now and you can read through these questions and have a go at each of them in turn using that equation. Okay, so I'm going to click on straight onto the answers for those questions, okay, and see how you got on. Okay, so the first one is giving you a measure for gravity, okay, or gravitational force, the acceleration due to gravity, which is 9.8 meters per second squared, and that's a value that you do actually need to remember. Okay, you may be asked to just use it without being given it. The second question was a simple equation where you just worked out the acceleration and was 11.2 meters per second squared. And finally, this space shuttle question involved a rearrangement of that equation. Okay, so they gave you the acceleration of 5.25, and you needed to multiply that acceleration by the time, which was 5 minutes, or 5 times 60, which is 300 seconds, and that gave you a velocity at that point of 1,575 meters per second. Okay, so very low acceleration, but quite a high velocity. So hopefully you got an okay with those. Now we're going to talk about something called uniform acceleration. Okay, so what do we mean by uniform acceleration? That's acceleration that is constant and does not change over a period of time. Okay, and we use this rather complicated looking equation to calculate uniform acceleration. Okay, so please make a note of that equation as well, where we have v, which is the final velocity, and u, which is the initial velocity. So this is looking at a change in velocity again, but it might be from a standing start, or it might be from a moving object that increases its velocity. We then look at the acceleration, which is a, and then s, which is the distance. Fortunately, this equation is given to you on the equation sheet in the exam, so it's not one you need to remember, but you do need to be able to use it, and you will need to be able to rearrange it. Okay, so to do that, I'd like you to try and attempt to rearrange the equation to find the following 4 objects. So to find the final velocity, to find the initial velocity, to find the acceleration, and to find the distance. Have a go, pause the video now and see if you can do that. Okay, how did you get on? Here is what you should have come up with. Okay, now some of these obviously are slightly more complicated than others, but if you've got, generally speaking, if you've got a square value, you need to take the square root of that value. Okay, so again, take a note of these equations if you haven't got them already. They'll just be something useful to keep to hand. Okay, they are complicated, and so that's why we're going to take just introduce them now, and we'll revisit these at the start of next year. Okay, so using that equation, okay, we're just going to have a go at a couple of questions. So again, I'd like you to pause the video and have a go at these questions. Okay, so we're asking you to calculate both the acceleration and the distance for these equations. Okay, so for the first one, the Peregrine Falcon, you should have come up with an acceleration of 15 meters, 15 meters per second, it should say, sorry, on that. So 15 meters per second using the information you can see in the equation. So an initial velocity of 30 and a final velocity of 90. Okay, and as you can see, using the equation 2s, sorry, we have 2 times the distance, which was 240, so it gave us 15 meters per second. For the second question, there was a 2-step process. So we had to work out the acceleration first, and that gave us 13.4 meters per second squared, and the distance from that was therefore 167.5 meters. So yes, just to clarify, question 1 here should be 15 meters per second squared for our acceleration. Okay, that's just missing from that bit of information. So hopefully those were okay for you. Just a little introduction to those. Okay, nothing more for the moment. The third task for you today is just a short home experiment to kind of look at this in action and do some calculations. So you're going to attempt to calculate the acceleration of an object due to gravity. Okay, the equipment you will need is on the left-hand side. So have a go at this, just to kind of visualize how this works. So you'll need a round object such as a tennis ball or a marble or anything that's that kind of shape. You'll need a tape measure or ruler or some way of measuring a distance. Okay, a stopwatch, access to a reasonably large drop of a few meters. Okay, and then something to provide a soft landing, obviously. Okay, you don't want your things breaking or bouncing too far away. You need to measure the height of your drop and record this as your distance, S. And then without adding any extra force, you just hold and drop the object that you have and record the time taken for it to reach the ground. So you may need some help with this step. Repeat that 10 times and then look at your results. Are there any that are too different from the others and you would consider unreliable? There might be that you know a reason for why a result is wrong. So maybe you started the stopwatch late, or maybe you were distracted or something. If so, then just discard it and repeat it to get 10 results. Then you need to take the mean of those measurements, and that will be your time. We're then going to use a different kind of equation just to have a go at calculating the acceleration due to gravity. So this equation here, S equals 0.5 gt squared, can be rearranged to give us the acceleration due to gravity. So S is your distance that you have measured. T, as I say, is your mean time or average time taken, which you will square and then you will half. Okay. And what I want you to do with your data is just compare your value for gravity with the actual value. So remember, we worked out earlier that the actual value for gravity on Earth should be 9.8 meters per second squared. Okay, so how does your value compare? Why might it be different? Just write a short conclusion to describe this. Okay, what you did and why it might not be 9.8. Okay, so calculated accurately, everything should have the same gravitational force on Earth. Okay, that was just a little bit of away from the computer work. The final task that you've got is a couple of exam questions just to kind of look at this in a bit more detail. So you can choose your level depending on which group you are in. You should be either doing the higher or the foundation. So there was a link to each of those there, and I will add those as separate links. They will take you to be able to add those directly online. I will also add them as attachments into the into Go for Schools and for Teams, so you can download them from there as well. And please submit your answers again via Teams if possible. If you're struggling with that, do email them so that I can then mark those and give you individual and whole class feedback. Okay, so that takes us to the end. Any questions, then please do email me, please, or contact me via Teams, okay? And I look forward to seeing the work that you have done. Okay, goodbye.